Hello everyone and welcome to Beginner's Code. Today we will be looking at object-oriented programming and how we can use inheritance to map real-world objects. Okay, so the first main thing that we need to understand about object-oriented programming is that it is usually used for real-world objects. So we use it to replicate these real-world objects. So for example, we could take a car. So we have a generic car, but then there are three different main types of a car. So we have petrol, we have diesel, and we also have electric. So, there's four if you then include hybrid. But each three of these different types all have their own attributes. So they will each have a chassis, a 4x set of wheels. I'm just going to comment that out. 4x set of wheels. They will also have a steering wheel. And then they'll also have things like electric plug-in parts. So the electric car will have a specific plug-in. The petrol will have a specific pump that can go in, and the same as diesel. So each of these have their own attributes. However, they all will have two specific methods, which will be accelerate and slow down. So that's going forwards and braking. So there's other things that they'll all be able to do, and they'll all have their own individual methods. So the reason why we are able to replicate real models in such a way is because we can create a very simple base class for the car that then the petrol can use, the diesel can use, and the electric can use, but they are all separate models. So the car is basically here being used as a blueprint for the other types of cars. So what do I mean by this? Well, if we were to start looking at, say, pets. So if we created a class and we called it cat. So inside of this, we obviously want a constructor method, so the initializer, so def __ init. And here we want to pass in the self parameter and then two extra parameters. So here we want a name and an age. And then what we'll do is self.name is equal to name and self.age is equal to age. And then we'll give it one method, and this will be to be able to speak. And we'll just print out meow. And then what we'll do now is we'll create a second class, and this will be called dog. So now we'll have another constructor with the name and age, and then self.name is equal to name and self.age equal to age. And then here what we want to do is have exactly the same, but we will print woof. So now we have two classes, one that's a cat, one that's a dog. They both have exactly the same attributes that are required. They both have the same methods, however they print out different values. So what we can actually do here, instead of having this put into both, because it is duplicating the code, it's messy, it's not very good, because if we wanted to add in self.legs is equal to legs, self.coat is equal to coat. So if we wanted to say that the cat had 4 legs and a brown coat, then if we wanted to do the same with the dog, we'd then have to manually type it in. Whereas what we can actually do is, if I just delete all of this, we can then create the base class. So we'll have a pet as a base class, which will have the initializer of self, name, and age. And then self.name is equal to name, self.age is equal to age. And then we could, for instance, put the speak method here. So we could say self and then print I don't know what to say just yet. And now we can create our extra classes. So class cat and this can instantiate from the pet, or this can inherit from the pet, sorry. So what we're doing here is we're using inheritance, and we are passing in this pet class as a parameter to this cat class. So we're using the object's attributes, the object's methods, and we're passing it through to this extra class that we're now creating. So we can now, because we've already got this here, and we don't need name and we don't need age, we can now just say def speak, and then self, and then print meow. And what we're doing here is we're actually going to be overwriting the speak method. So now if I instantiated this, so C1 is equal to cat, and what we'll do is we'll pass in, say, Ada and the value of 3. And now if I was to do C1.speak, and then if I headed over to my desktop, which I'm already in, and then Python, so what we actually get back is meow. And we're getting this back because this method here has been created, but because we have one here, it overwrites this method. So what I mean by this is if I create the dog class that also instantiates from the pet, and if we just say def, and we create one called hungry, and then self, and then print woof. Now, if I instantiated this dog class, so D1, and we just said, say, Frank and the value of 6, and then if I said D1.speak, and if I head over to here, now we get meow, and then we get I don't know what to say just yet. And that's because we have this speak method, and it is accessible to D1 because the dog is inheriting these methods and attributes. So we can access this speak. However, if I was to say do d1.hungry and then ran it, we would then get woof underneath, and that's because we now have this extra method. But if I was to add in speak as a method here for the dog, and then print woof with a capital F, and now if we run it, we have woof with a capital F printed out in instead of I don't know what to say just yet, and that's because we're now overwriting this speak method. So the last thing that I want to speak about quickly is just extra attributes. So you'll notice up here we have name and age, and in the previous 5 minutes ago I said that we could add self.legs and self.coat. And it would have had to have been added to both. However, now, if we wanted to say just give the cat the legs and just say give the dog the breed or something, then what we can do here is we can actually add in the initializing method. And then we can say self, name, age, and then for dog we'll say breed. And then because we already have the name and the age, because we're inheriting from this, what we can do is we can say super dot underscore underscore init, and now we pass in name and age. So this is actually taking from the super class the instructor methods, and it is passing them into these two attributes that we have here. So we don't actually need to pass in self as a parameter here. But what we can do now is self.breed is equal to breed. And then if we do the same for the cat, so we'll do legs for the cat, self, name, age, legs, and then super dot init, name, age, and then self.legs is equal to legs. So now if I was to say, we'd need a breed for the dog. So if we passed in, say, German Husky. And then for the cat, if we said 4, because it has 4 legs. Now, if I just delete these 3 and then do c1.legs, And if I just print this out and then print d1.breed, and if we run this, we get 4 because the cat now has 4 legs, and the German Husky is printed out for the breed of the dog. But if I was to say change this to D1 and this to C1, then we should get errors because the dog doesn't have legs and the cat doesn't have a breed. So yep, dog object has no attribute legs. Thank you for watching. Hopefully this has helped your understanding of object-oriented programming and how we can use it to create multiple versions of objects with only a small amount of code. If you liked what we've been through and you want to learn more, please drop a like and subscribe to my channel to keep up to date. Next time, we will be looking at creating a banking system that we can use to keep track of deposits, withdrawals, and our total balance. Thank you, and I'll see you next time.